This video has subtitles for people with hearing difficulties or who have difficulty with my voice. If you find the subtitles distracting, please go to the other video on this site which has no subtitles. Surface area of a frustum by Namkang. I hope you like it! Don't forget to use your space bar or your keyboard key K to pause your video and to make notes if you want to. A frustum is just a posh word for a section of a cone that has had its top cropped off. Remember it as a frustrated cone because it really wants to be a proper cone, but no one will let it. For simplicity, we will call capital H big H and use big H to label the full slant height of the cone, including the cropped off top. Label the slant height of the frustum small h. Label the radius of the top of the frustum R1. It will be equal to the length of the radius of the base of the top section, which we will also label as R1. Label the bottom of the radius of the frustum as R2. Label the surface area of the sides of the frustum as SF. Label the surface area of the sides of the cropped off top as ST. Label the surface area of the combined figure as SC. The surface area of the frustum is obtained by taking away the surface area of the top from the surface area of the whole figure. So, SF equals SC minus ST. If we are given a frustum, we know the values of R1 for the top radius and R2 for the bottom radius, and the slant height small h, or we can measure them. But big H is an unknown quantity. We have to find an expression so we can substitute for the unknown quantity big H with some terms whose values we know, such as R1, R2, and small h. Focus on Fig 3. We can reason that the ratio of R1 to R2 is the same ratio as big H minus small h is to big H. So we can write R1 over R2 is equal to big H minus small h over big H. Rearranging these terms by cross multiplication, we can obtain R1 times big H is equal to R2 times big H minus R2 times small h. Further rearrangement gives R2 times small h is equal to big H times R2 minus R1. Finally, we can express big H as equal to R2 times small h over R2 minus R1. So we have expressed our unknown big H in terms of our known quantities R1, R2, and small h. We can now substitute into SF equals SC minus ST. SC, which is pi times R2 times big H, and ST, which is pi times R1 times big H minus small h, giving SF equals pi times R2 times big H minus pi times R1 times big H minus small h. Multiplying out the brackets gives pi times R2 times big H minus pi times R1 times big H plus pi times R1 times small h, which can be further rearranged to give pi times big H times in brackets R2 minus R1 plus pi times R1 times small h. Now substitute for big H with the expression we derived beforehand, which was big H equals R2 times small h over R2 minus R1. Then cancel out the brackets, R2 minus R1 from the top and bottom. We are left with SF equals pi times R2 times small h plus pi times R1 times small h. So the surface area of the sides of a frustum are equal to pi times h times the sum of R1 plus R2. If we want to complete the surface area of the frustum, including the two ends, we simply add pi times R1 squared and pi times R2 squared to the above equation.